Welcome to Code and Concrete, the leading podcast for prop tech, conversations about the built environment, and other innovations. Code and Concrete is produced by Building Inc. and hosted by yours truly, Matthew Schneider. If you enjoyed this episode, be sure to follow and rate 5 stars. David Gory is the co-founder and CEO of Airbuild Inc., a climate technology company focused on innovative solutions to clean air, water, and capture carbon through microalgae and biochar technologies. With a strong background in engineering and business, David draws inspiration from his upbringing in Nigeria, where firsthand experiences with pollution fueled his commitment to sustainability and social impact. Under his leadership, Airbuild pioneers scalable, practical technologies that benefit communities globally by delivering cleaner environments and creating economic value. David, thank you for coming on to Code and Concrete.
Oh, thank you very much for having me.
So there's a lot to cover today. I have to admit, these are topics that I'm not an expert in, but I think it has a massive impact on the built environment and the natural environment. So I'm really excited to discuss how these things overlap and specifically what you're doing to remedy some of the issues that we're seeing in terms of our natural environment and pollution and all of those elements. So first, I want to start with you so that we can get to know a little bit more about you. You mentioned that you grew up in Nigeria, and then we haven't talked about where you are now. Let's go through that entrepreneurial journey. What was childhood like? Where did you first find interest in the sustainability? And then where are you now? How's the company coming along?
Yes, thank you very much for that question. I was born and raised in Nigeria. I grew up I was born right outside Gory, in a small city called Eku. My mom was going to college at the time. Spent the first 6 years of my life over there, primary, secondary school, elementary school, only child of my parents. And they were brave enough to send me to a whole nother continent for college. So I left Nigeria at 16, came to the US, when moved to Cleveland, Ohio, because my cousin's husband was doing residency at Cleveland Clinic at the time, so was still theoretically close to family. Went to Cleveland State University, got my undergrad in mechanical engineering, met one of my closest friends, Himanshu Mohare, who was a co-founder of Airbuild previously, and introduced me to John Booker, who's my current co-founder. We met when I was getting my undergrad in mechanical engineering, like I said. Fast forward, after that, I went back for my MBA. And during my MBA program, I randomly called him on like a Thursday just to check in. And he was like, hey, I met this guy on LinkedIn and we're talking of starting a company that will decentralize carbon capture. And I was like, interesting, tell me more. So he told me a whole lot more about it, and I was very interested. He connected me with John the next day. After one conversation, I literally told John I'm in. And that's how Airbuild was born. We took the idea, ran with it, reiterated, pivoted, a lot of times. There were times where we would build a prototype, send it to the lab, it would fail, we would go back, cry, come back and, build again, because that's kind of what you should do when you really want to fight for something. So we did that a couple of times, well, more than a couple of times. And fast forward, moved to Portland, Oregon after I got my MBA, was working as a sales engineer over here while still nursing and trying to build out the company. We hit a big milestone in August of 2023 when we got into Techstars. Techstars is one of the largest accelerator programs in the world, and I think they're like number 2 in the largest pre-seed investors. So we got into Techstars. When our prototype finally worked, I quit my job, moved to San Diego, started working, with John on site, working with the business development and all that. Also, I actually forgot to add this. While I was in Portland, Oregon, I felt like my life wasn't complicated enough. So I decided to go back to school for another master's in cybersecurity, which is a degree that I don't like talking about because I've never used it. Let's not go into that. So yeah, that's kind of my personal story of how we got into it. From Techstars, we started cooking with gas, got introduced to customers, investors, and have been leveraging their network ever since.
Well, let's talk about Airbuild. What is the company? What is your prototype? And I'm actually curious, how was your experience working with Techstars? And did that have any influence over your product as it was being developed?
Yes, it did. So we build self-powered systems that utilize microalgae to capture carbon and treat polluted beds of water. So polluted rivers, polluted lakes, municipal sewer lagoons, because those still exist where wastewater is pumped into holes in the ground and either slowly treated or just left there. So we deploy next to those polluted beds. We take that water in. Microalgae captures the pollutants from the water, from microplastics, PFAS, excess nutrients, heavy metals, outcompetes other contaminants like E. coli, while also capturing carbon because that organism is so annoying and special. Yes, annoying and special. It's responsible for 50% of the carbon capture on the planet as we know it today, but it's also in every polluted bed of water trying to do its job. All we're doing is creating an environment for that. So we deploy next to those polluted beds, pump the water in. The algae does its job. We send that solution into our harvester where it splits between the microalgae and the treated water. We send the water down to secondary and tertiary treatment, and the water that we discharge exceeds EPA discharge standards. That clean water goes into, that polluted stream and dilutes the level of pollution in that water. And just, like the concept of recycling, if you do that a number of times, you're cleaning the water in that space. And that's really where our bioremediation efforts come in. The microalgae, on the other end, we take that and we combine that with local organic waste. So waste like agricultural waste, animal waste that typically would have been incinerated or landfilled, which are terrible for the environment. We mix that biomass cocktail and we pyrolyze that, which is heating it in the absence of oxygen to create biochar, biological charcoal, which is great for permanent carbon storage over 1,000-year permanence, as well as biofertilizer for local farmers. And there's also a growing industry for biochar. Every day I wake up and I learn something new about it. It's being used to replace graphite in sodium-ion batteries. It's being used in supercapacitors. It's being used in concrete and cement, in ink, in insulation for buildings. Amazing product in itself. And to answer your second question, Techstars was amazing for us. Techstars was my first taste in entrepreneurship. I always felt like I wanted to be an entrepreneur growing up. I saw my dad start a few businesses. My mom did as well. And the ability to create your own destiny, the ability to control your own destiny. I know fully well that you eat what you kill, which is also why I love sales and why I chose to go into sales engineering with my engineering degree, because you eat what you kill. If you don't work, you don't eat, right? You're in control of your fate. And that's what sales, provides for salespeople. And that's something that has always, resonated with me. So I've always thought about it, had ideas. But when Airbuild was introduced to me by my co-founder, John, it sounded like a win and a no-brainer. So Techstars was very helpful, to us in the learnings. As a first-time entrepreneur, I learned so much from the program, Ryan Kuder, Misty, and really everyone in the program, the other entrepreneurs. And since then, we've gone through a handful of other programs, to name a few. World Economic Forum with the SSF, we're part of the top innovators. We're currently going through NASDAQ Milestone Makers, Generator. And we go through these not only to grow our network, but also to learn, because there's so many things you can learn. And my dad always said growing up that a foolish man waits to make his own mistakes, but a wise man learns from the mistake of others. And I pride myself on being more wise than foolish.
I love that. Wow. Okay. Well, that's phenomenal that the accelerators have been resourceful to you. And I want to unpack the R&D process and maybe if the accelerators helped out or if that's been a lot of your team's own efforts, because I imagine that R&D for a product like this, and we're going to put product in parentheses or in quotations because it's not your typical product. So a lot of people are familiar with software platforms or something that you're going to purchase at the store, but this functions a little bit differently. So what was it like developing this? And then how are you delivering this to the sites that need to be fixed? These bodies of water, who do you speak with? How do you convince them to use this? And how do you turn that into a business model?
So to answer the last question first, we actually built it like Legos on site. So we pretty much cut out the transportation hurdle, because transporting something that big. I mean, we drive and we see all those trucks that have heavy duty, and you can't even be anywhere close to them. No, we cut that out. We build our deployments on sites, and we talk to city managers, we talk to mayors, we talk to economic development committees, and we talk to the port. So the people who are seeing these water problems, even your everyday people complain. There was a period in New York where you couldn't drink from the faucets. Texas is going through that right now. There are places where you travel to in the country that you run the water from the faucet, and you go, nope, I'm going to go buy a bottled water. The constituents see that, and cities also have their sustainability reports that they publish every year. Every city has one. And when you see that, you see that the biggest outcry from the community is we want clean water, we want clean air, we want economic opportunity, we want jobs. And we look through those and we just went, okay, these are the people who publish these reports. These are the people we need to reach out to and to share our solution with. The programs that we've gone through, every single one of them has been immensely beneficial, because to build something like this, to build anything, it takes a village. No one can, do it themselves. And I've always been a believer of your network is your net worth. And we are leveraging, the organizations that we're part of, that we've participated in for their network. And they do have, great networks. So that's definitely something that we've benefited from them. And on the R&D side, if you are building something that no one's going to pay for, regardless of how fascinating it is, you're just building a science experiment. So you need to go out there and talk to the customers. You need to understand the customer's mindset. You need to find who's paying and understand why they're paying and what they're willing to pay for and what they care about. And that's what those programs have helped us with. So I will give them a lot of credit for R&D efforts. All our pivots have really come from either an introduction to a customer or a question that one of the people in the program or somebody in our network has asked, and we've gone, I don't think we have an answer to that question. We're going to get back to you on it. We go, we research, we talk to people, and we're like, you're right. We're not going to do this. We're going to do this instead, because that's what the customer's passionate about.
There's a couple things a couple different directions to take this conversation. First, I want to ask, would it be accurate to describe this as like a circular economy, circular concept, where if you look at the life cycle of goods, you are essentially encouraging the recycling or the reusability? I might not have the correct terminology. Do you think this falls into that category? And if so, what is the proper way to describe the things that I'm trying to get across?
You actually nailed it. It's all a circular economy play. It's the, people call it waste to value. People call it circular economy. People call it recycling. It really depends on, the verbiage that you want to use, but it all means the same thing. We're taking waste, literal waste, wastewater, waste from the air, which is the carbon, and literal waste from the cities, which is the organic waste. And we're turning that into a raw material that feeds industries. We're turning that into a material that can reclaim the soil. We're turning that into a material that fixes polluted soil from like mining spills, because biochar is great for soil remediation. There's a whole, market for that. It replaces biofertilizers for farmers. So it's the full waste to value play. And I kind of call it a bundle and save, because you see companies that focus on one and only, take waste from one subset and, do that. But we feel like the problems are interconnected, so the solution should be as well.
Right. And speaking of connectivity, thinking about the built environment, So our podcast talks a lot about the built environment and whether that's how to architect and engineer buildings properly so that they're more efficient or safer or just look better or more cost efficient. There's also the sustainability element. And I think that a lot of real estate developers have neglected the consideration for what waste is produced by these buildings, either in the construction process or later in the life cycle during operations or during decommissioning. So how do you see in the overarching umbrella of smart cities, which is kind of where I see an overlap here, how do you see microalgae and biochar contributing to sustainability goals that cities might have? And this is abstract, but trying to connect it back to my thinking, is there any real impact that this might have on infrastructure or buildings? Where can we start connecting the dots here?
The answer is yes and yes. We have an impact on the way the cities live. We have the impact on the way the constituents in the cities live. We have an impact on buildings. We have an impact on water. We have an impact on infrastructure because those are things that we need to survive. If you look at the way technology has developed over the years, the land that we currently have are concrete jungles, which we call our cities, was previously farmlands. They had forests, they had crops, they had trees, and trees breathing carbon release oxygen, right? Which is balancing that cycle. But we always get rid of nature to build our much needed infrastructure. We need those because that's how we advance as a species. But there has to be that back end correction, which is why we talk about climate change and the amount of carbon emissions and how we run out of resources, because that correction doesn't exist. And that's what we're trying to do. Not only from the carbon capture part or the water treatment part, but I feel the biochar is a big piece to this. We can utilize that biochar in concrete and cement, thereby decarbonizing that industry and making our cities more breathable. New York has air quality problems. LA has air quality problems. And we're seeing that in more countries on all continents. So this is not just, a US thing. But if we start using sustainable materials in our development of this, much needed infrastructure, then we're kind of evening out that balance. And I think that's kind of where the planet should be leaning towards. We should be leaning towards that equilibrium. If you chop off a tree here, plant one here, right? Restore that balance, because math is something that you cannot bullshit.
Well, let's talk about the biochar. What are all the different applications for this?
So right now, our chosen application is land application. So we pour the biochar on land for farmers to help them with water retention, nutrient retention, and soil retention, because it helps their plants grow faster. Interesting factoid. There's a company called HiveGeo out of UAE. They're the only company that's producing biochar the way we are. And their goal is to regreen the desert. They're taking that biochar, spraying it over the desert with the goal of planting food in the desert to solve the Middle East food crisis. That's the power of biochar and a testament to the power of algae-infused biochar. So that's the food play for it. And then there are companies like Bioforce Tech that's utilizing biochar, and from the biochar, they're making ink that can go on t-shirts, designs for cups, and a bunch of other products. There are companies that are like Solid Carbon that are turning biochar into concrete and cement. There's a company out of Arizona that's turning it into asphalt. There's actually a company I just talked to out of New York that's turning it into insulation for buildings. So there's so many fascinating products that are coming from this raw material. And all we have to do, what we should do, is increase the supply of this material so that the industries keep growing and we start having sustainable manufacturing, because that's something we should be leaning towards.
That's incredible. It's incredible how many different use cases there are for biochar. What do you think is going to be the most, I'm going to phrase it in two ways, the most valuable to the earth, and then the most valuable in terms of market capitalization, market size?
I love to say that we can walk and chew gum at the same time. So I believe they're not mutually exclusive.
Right.
They are manufacturers that are facing either one of those. Some are facing concrete, asphalt, window insulation, batteries, energy generation, land reclamation, water reclamation as well. I don't know if there's anyone I would pick as the most impactful. I think they're all very much needed. So it's our jobs, and Airbuild is, part of the companies that's lucky enough to take on this challenge to increase the supply. Because if we can increase the supply, then we can handle the demand across all those industries. We've kind of seen that happen with the automobile industry, where all they had to do was increase the supply of the types of cars, number of cars. And now there are cars available for people to purchase. We're trying to do the same with climate solutions.
You mentioned the UAE. What markets are you focused on? What markets would you like to focus on? And what's the fastest growing? Is this a concept that is very popular in the EU or the US because we politicize climate change? Where are you seeing these trends?
Right now, right in the year 2025, it's growing a whole lot faster internationally than in the US. It's growing faster in Europe, Asia, and interestingly enough, Africa, than the US. But that's only because of the climate that we find ourselves in. The US is traditionally one of the fastest, growers in terms of adoption of our solutions, which is why companies come here. But we're focusing on the US right now, because this is where we're located. This is where our demonstration facility is. This is where we've seen a lot of our customer traction. And we also operate under the hypothesis of, if we can prove this out here, we can aggressively scale. We've seen that happen to thousands of companies, and we just want to be one of those. Our vision is to scale this globally. Like I said, like you all know, I am from Nigeria, where we had to drink water from wells because our natural water resources were polluted. My other co-founder, Dr. Richard Marita, lost his mother and sister to waterborne diseases in Kenya. So the goal for Airbuild and our vision is to scale this globally to make sure that people in those situations do not face the same fate. We are very mission driven and operate under the hypothesis and the belief that mission and economics are not mutually exclusive. So we can pursue both, and that's really what we're working to do. So the goal is starting here, scale to Europe, scale to Asia, scale to Southern America, scale to the Middle East, scale to Africa, because this problem is global. It's estimated that in 5 years, we're going to run out of water. There's going to be a 40% surplus of demand than supply. Currently, today, over 2.3 billion people lack access to clean water. So we're already seeing the fragmentation of the infrastructure and seeing the problems as they are. And data centers are big water suckers. So as that industry scales, again, AI is very much needed. As that industry scales, we need to also scale on the other end just as fast, or twice as fast, or 10 times as fast, to ensure that there's that balance, that I talked about in my first spiel.
Well, that's a fantastic point. Our infrastructure globally is not keeping up with the demands, either from data centers and artificial intelligence or just growing populations. It's
Yes.
a fractured infrastructure, is fractured all around the world. It is fragmented. It is facing all sorts of issues. And then we compromise our own infrastructure, sometimes for political reasons or geopolitical, such as war. So it's this issue that is certainly going to be becoming worse. And there's a lot of people in countries that are maybe ignorant to just how critical this issue is and how many people are impacted. You're starting to see a shift a little bit where people recognize that maybe for the longest time they only had first world problems to deal with, and now they're being impacted. They're saying, wow, I don't want that data center near me because I turn on the tap and the water's not coming out, or my energy bill is quadrupling, or
Yes.
I'm trying to cross the road and I've got all these issues. Our cities are planned terribly, and what's that smell in the air? So people may have been safeguarded from a lot of these issues for a while, and the chickens are coming home to roost, to say the
Yeah.
least. Now, a bit of a tangent, but I was curious, is there any sort of regulatory restriction on the use of microalgae or biochar? Or is this a solution that is generally easy to roll out?
It's fairly easy to roll out. There are permits that you need to get because again, we need to be the environmental agencies need to be sure that you're on the up and up. And for us, we are very transparent in our processes. Microalgae is, like I said, is aggressively present in every polluted bed of water, but you do not want that abundant in your waterways. I live in Portland, Oregon, and at the start of the summer of this year, I got like 7 alerts saying, "Hey, do not take your personal water device to this lake or to this river because of toxic algae blooms." And that's because of the pollutants that are in that water that's leading to the toxic bloom. So if we were utilizing, say, we are utilizing microalgae to treat water, but if we're just running the water with the algae into the river, then we're worsening that situation, and that's something we'll be environmentally liable for. So we do have processes in place, and we've worked with, in Utah, where we currently have our demo, we've worked with the Department of Water Quality, the Department of Water Rights, and the Department of Water Safety to ensure that we are on the up and up, educating them on our process. Somebody from Water Rights was actually at our facility earlier this week to tour and see how everything is going and to make sure that we environmentally comply. So we utilize the microalgae for that process, but we do not send the algae down to the river again, because if you do so, you're worsening that situation. At the same time, with the biochar, there is an emission component to it because you're creating heat and you can't just let that precipitate. So if you do so, you're worsening the environment. But our equipment manufacturers and the people we've been talking to, they have emission standards that they hit, and those are things that you have to submit to the environmental agencies. So my way of saying that is too much of anything is bad, right? But if it's moderately controlled, you're in the green. And that's kind of how we have to be as a country, as a people, and as a species.
Before we talk about carbon credits, which is where I'd like to jump to next, because I'm sure there's a relationship, I do want to ask on the topic of regulation, are there just objections in general that you receive? Perhaps, what if this goes wrong, or what if you worsen the situation? And if so, what are they? And what is your typical rebuttal?
So we always think of the what ifs. We have a lot of smart people on my team who plan for the doomsday scenario because you never want to be caught off guard. And that was a question we asked, in Utah when we're talking to them about, in Green River, Utah, when we talked to them about our solution. And our answer was, I promise you this much, the water will never leave worse than it came in. And we explained, our process. It will always leave better. And that's really something that we have to be grateful to technology for, because we can test. I worked in IoT in my former life, and I'm doing a lot of work with IoT now, where we have sensors at every part of our solution, the inlet, the outlet, and we're always getting that data, because that data is what ensures that we are credible. We're not only getting the data ourselves in-house, we're also getting third-party data. We're currently in the process of sending our first samples out to a lab for them to test. And they would so it won't be our own biased opinion, it would be an unbiased third party's opinion. So those are things that we, again, show and report to these agencies. And that was really the first question we got asked. It is, there's no way you guys are going to send this water out worse than it came in, right? Because you're treating the water. And our answer was yes.
Okay. So I definitely want to talk about IoT, but first things first. So the carbon credit portion, what is the relationship to this? Because the biochar is sequestering carbon. What's the life cycle of a carbon credit in the context of biochar?
Yes. So there are companies that currently have methodologies. There's your Isometric, who we are currently partnered with, already listed on their website. Go check us out. There are also your Pure Earth, your Vera, and these companies have developed methodologies through rigorous, science that shows that carbon can be stored in various forms. There are companies like your direct air capture companies that capture the carbon and store it underground. And then there's a permanence attached to that. How long does that carbon stay underground? Is it like a worm? Is it going to eventually sip its way out? Or is it just going to stay there? And then there are other processes that do in limestone. There are companies that bury in the ocean. And then there's us that do biochar. Each ton of biochar holds 2.4 tons of carbon, roughly. Depending, and there's still a lot of science that's going into this and a lot of research constantly that goes into this, but isometric has this standard that there are two different permanent structures based on the reflectivity of the biochar. You can tell if the carbon is going to be stored in that biochar for 100 years, or if it's going to be stored in there for 1,000 years or over 1,000 years. And depending on the quality of the biochar that you make, that establishes your permanence. But to qualify for carbon offsets, there's the capture component and there's the storage component. And our capture component is biochar, is microalgae, as well as the organic waste. And then our storage is the biochar, which unlocks that for us.
So in this case, the carbon credits are being rewarded to you, your company, or?
Yes, they are. We get the carbon offsets and then we can then sell them on the voluntary carbon market or the compliance carbon market, depending on what the purchasers are looking for. And this helps those purchasers offsets their emissions, which goes back to one of the first things that I said, which is if you cut a tree off here, you plant a tree here for that balance. And that's really what the carbon markets is. It's definitely not endorsing or supporting the concept of continue cutting off trees. It's just one of the things where with the planet the way it is today, you need to do something to make it up. We need to start that rebalancing act so that we can get this planet back to a healthy status.
Right. I like that term, rebalancing the planet. Well, let's talk about IoT. So we're huge advocates of IoT because of that raw data feed that stakeholders are receiving from infrastructure assets or buildings or everything in between, right? There's all sorts of biological sensors, there's engineering and load bearing. I guess walk us through the type of sensors that you are deploying or would be deploying and what type of data that is and who it's being delivered to. And what format? Is this going to a dashboard? Is this a platform that you offer or someone else?
So it's going to a dashboard. It is also a platform that we offer because we want full transparency. We share this with our customers. So a city manager, a mayor can look and go, okay, we've treated X amount of water per day. This is the amount of biochar that we've created. So this is the amount of carbon that we've captured. So we've cleaned the air to this percent. This is the amount of waste that we've diverted from a landfill. This is the amount of waste that we've diverted from incineration. We track all that. So for our process, we use a variety of water quality sensors. We also have your dissolved CO2 sensors, dissolved oxygen sensors, your pH sensors, the sensors that are necessary for algal cultivation, because all we're doing is creating the optimal environment for algae to thrive. So we need to monitor and regulate. We see the product, the Airbuild pod, as its own greenhouse. And if you have a greenhouse, you want to know the temperature, you want to know the flow, you want to know the air quality, and those are things that we monitor. On the other side, we also monitor the amount of waste that's coming in, the pyrolysis efficiency, the emissions from that machine, as well as the amount of heat that's being produced and the efficiency of that process as well. And we not only have to report this information to the departments, the environmental departments, we have to report them to our registering agency being isometric as well, because they need to know, because if we are doing more harm than good, we do not qualify for the carbon offset. So that is also a way of ensuring that we are being compliant and we are speaking to and acting in that concept of do no harm.
Wow. Well, super cool. I'm learning so much here. This is new territory for me, but it is really fascinating. And I mean, I'm really speaking from a place of humility. I'm trying to catch up. I'm trying to use all the lingo and give you a fantastic conversation. And I think we've done a good job of that. And I mean, you know this stuff in and out, and I feel enlightened just after talking for a half hour about all of this. In fact, I've got some gears spinning in my head. Like I'm already thinking, okay, this is how it could be applied here or there, or I recognize that word, and this is how it applies to something I'm doing. So it's really fascinating. But to shift gears a little bit and not talk about the industry, I just want to talk about leadership in general, especially in climate tech, because you are in a vertical that it can be politicized, it can be questioned. It's certainly difficult to roll out. Sometimes it relies on subsidies or government funding in order to succeed. Right? If you look at electric vehicles, that was a big thing. That industry grew very quickly because there was federal funding for it, and then as that begins to dry up, people are like, okay, I'm done buying the electric vehicle. I'm not getting the tax credits, or the manufacturers just can't produce it. So what battles do you feel that you are up against, and how has it been for you as a leader in this space navigating all of that?
There are a lot of battles that we face in the clean space. I mean, you use the reference of the EVs and the electric vehicles. When you are working on something, up until you hit that scale, it's really hard to make the unit economics low to compete with your traditional products. And there's a reason why we have, a lot of fossil fuel products today, because they're very cost effective. Years ago, I think about 20 years ago, billions of dollars were spent on microalgae cultivation for biofuel, because the story, which is a very powerful story, was if you are cultivating algae, which is capturing carbon, and you're creating fuel from that algae, and the fuel, you're burning the fuel that releases the carbon again, you're keeping the level of pollution constant. It's just a cycle, as opposed to creating new fuel, which is creating new carbon emissions. Powerful story, powerful industry. They started working, they were able to prove it out, but they could never get the unit economics to work. The EV industry then came, and we saw exactly what happened with the federal incentives that kind of led to that resurgence. Biochar itself is not novel. Biochar has been around for thousands of years. There's so many different ways to make it. But the reason why it's becoming more mainstream right now is because of the carbon market. And that's something that has been aggressively politicized, at least here in this country. We're talking to people who do not believe in the market. We're talking to people who poke holes, who object to the existence of the market and pretty much want the market gone, right? But the thing with that is, and my argument has always been, if you get rid of that, you're getting rid of the green incentive. I understand you're making people, build smarter, cheaper, faster, better, which is what everybody wants. But at the early stage, you do need that nudge. So that's something that we're currently navigating as a company in this space. Luckily enough for us, and I understand it's something that not everyone can, talk about or boast of. But luckily enough for us, the water treatment component of our solution is cheaper, faster, better. Our pitch to cities is we hit the water quality and the volumetric capacity of your $60 million water membrane-based water treatment plant for the price of a municipal sewer lagoon. So the amount of money we're going to pay for that terrible, environmentally destroying solution, you could pay that to us and we'll be able to hit, the volumetric capacity of a $60 million plant. So we're roughly 50% cheaper, 35 to 50, depending on the city space, than the existing solutions on the market. But that's our own, personal story. And there are a lot of industries in our space that need that subsidy. We are in a climate where we need to do better. We need to start working on that rebalancing act. So I empathize with all the other founders and entrepreneurs and individuals in our space who have to currently navigate the political space, but it does get better.
What's a good piece of advice for a founder in climate tech? What was something that kept you going and maybe even gave you a breakthrough? It sounds like you guys are doing pretty well. So if there was something you look back on the time that you've spent in this vertical, what would you like other founders, other builders to know?
What kept us going, and there have been a lot of dark days. We feel like the day is still dark. I don't think it's dawn yet. what kept us going is the mission. We stayed true to ourselves as a team, and that is something that has shown, itself in every single member of the company. I cannot appreciate my team enough for their trust and the faith that they have in me and in the company, and the belief that we can do things better. So the mission and the story, like I've said, our own personal experiences is what drives us and what keeps us breathing, even when it feels like we should be drowning. So my advice to other climate entrepreneurs out there is stay true to yourself, stay true to your mission. You see the problem. If it's your lived experience or if it's something you've seen and witnessed, you've seen the problem. Develop a solution for the problem. But also remember, if you build something that no one will pay for, you have a scientific experiment. So go out there, find customers, find people that are willing to pay for what you're building, pivot if necessary, and always work hand in hand with your customers. Because if you don't work with them, then again, you're building something that you don't know if someone will pay for. Work with your customers, build what they will pay for, and everything else will fall into place. It feels like a lonely journey. It's a hard journey because if it wasn't, everybody would do it. They always say, if wishes were horses, beggars would ride. So keep wishing, keep running, and you will be successful.
Beautiful. Beautiful. I almost want to wrap up there, but I always give folks a call to action because that's like a wonderful mic drop. That's like, boom. But what do you have coming up? How can people get involved? Who are you looking for? Whatever. Floor is yours.
Shameless plug. My co-founder John and I just got announced as Forbes 30 under 30. So we are breathing that in and celebrating that internally right now. But we're still working. So we are deploying in Green River, Utah. We already have a commercial demo. We're working to scale that to a commercial pilot. We should be able to have our water quality samples and results hopefully by end of January. And we're working to come to a city near you. So keep complaining to your congressman and your city officials about the environmental problems you're seeing. And hopefully Airbuild can be one of the solutions that comes to fix that problem.
Beautiful. Spoken like a true founder. Awesome. Well, David, thank you so much for coming on the show. This has been such an insightful conversation for me. New territory, but in very important territory. The sustainability element cannot be left out of the built environment equation. It's not all about profits and progress. We have to sometimes put on the brakes and ask the question of who is this impacting, or not just who, but what. And that's the environment. So again, thanks so much. I'm going to have links to all of your stuff in the show notes, and I certainly encourage people to reach out, find a way to get involved. You're doing very impactful stuff. And for all of our listeners, of course, if you enjoy the conversation with David or any of the past conversations on Code and Concrete, always leave a like or 5 stars, subscribe, whatever you want to do, whatever platform you're on. It really helps us out. So thank you, David. Really appreciate it.
Thank you very much, Matthew. I appreciate you taking the time and the platform. Like and subscribe.
Yes. Perfect. All right. Well, you take care now. All right.
All right. Thank you.